Okay, we are looking at circle theorem 1. Circle theorem 1. The angle at the center is twice the one at the circumference. So we want to look at this theorem and prove it. We want to prove the theorem. So given a circle, where you are given an arc, this is a circle with an arc. This is the first arc. The second arc join. This is the first line and second line. They join at this point to form an arc. So we can label this point, the first point, as A, and label the second line as B, where it meets with the circumference. So this A can, so we label this A and B. So this is our arc AB. So they meet at a point O at the center, which we labeled as point O. So this point A, which is the arc, point A can be extended to the circumference, and this B can be also be extended to the circumference, and they will meet at a point on the circumference. So look at it. So you draw a line, both of them meeting at a point on the circumference. So this place where they meet, we can label that point as C. We can label it as C. So this is point C. So we now have ABC. This is the point where the lines touch the circle on the circumference. So we want to prove that the angle at the center is twice the one at the circumference. So this is the angle at the center, twice the one at the circumference. This is what we want to prove. AOB, because trace the line AOB is twice ACB. So if you look at this, you see that the angle is at O and C. So let us label the angle. The angle is at O and on C. So we label it. This is the angle. It means that the angle is on O and C. So we go on to prove this. So we are going to bisect this angle C and O. So we draw a line. So this is a line. So this. So we'll see that the angle is on O and C. So we label it O and C, angle O and angle C. So we go on to prove this. Bisect this angle O and C by drawing a line that will pass through C and O. So we draw a line. So after drawing this line, you see that we have formed two triangles in this shape. We have two triangles, triangle ACO, triangle 1 and triangle 2. And we have triangle BCO. So here, if you look at this triangle, you see that the two sides are equal. So since the two sides are equal in triangle 1, that means it's an isosceles triangle. And remember the theorem of isosceles triangle. If the two sides are equal, that means the base angles are equal. And this is the base angle. This is the base angles. So now we can label the base angle as S. So if here is S, that means here is also S in triangle 1. So in triangle 2, BCO, we can label here BCO as Y, and CBO will equally be Y. So now we are done with the two triangles. Go over to angle O, which we bisected. So we can label this angle O because we have cut the angle into two. We can label here to be E and here to be F. So we have two E angles there, E and F, representing angle O. So we go on to use this theorem, another theorem of triangle. We say that S plus S equal to E, Y plus Y equal to F. This theorem is from the sum of two interior angles is equal to one opposite exterior angle. It's a theorem of a triangle, that these two angles, which are interior angles, they are equal to the external angle, opposite external angle. So that's why we have this in the. So we are going to simplify this equation. S plus S is 2S and is equal to E, which is equation 1. Y plus Y is 2Y equal to F. We call it our equation 2. So we can go on and add the two equations, equation 1 and equation 2. So if I add these two equations, I'll have 2S plus 2Y 2x plus 2y is this, and e plus f. So 2x plus 2y equal to e plus f. So if you look at this, 2 is common, so we factor out 2, opening a bracket, we have 2 into bracket x plus y, which is equal to e plus f. So if you look at this x plus y, go back to the diagram, you see that x plus y is the whole of this angle C. So x plus y is angle C. So we trace the line, you see it's at AC, this is CB. So we have ACB, ACB. So we can replace x plus y with ACB. So we have now 2 ACB equal to E plus F. Going back to the diagram, represents O. So if we trace this angle E and F back to the circumference, you see A, back to the other circumference, you see B. So this is AOB. So we can represent E, replace E plus F with AOB, because that is where the angle is. So finally we can see that the theorem has been proved. The theorem we are asked to prove, we have done that. So we can see that the angle at the center is twice the one at the circumference. So we have finally proved this. So when you are given any question or problem regarding this theorem, we can always remember to use this theorem. Thank you.